Hello, I'm Minyoung Park from Dongguk University, and I will presenting the paper titled that the acceptance and uses of smart connected objects according to adoption stages for diffusion models. The contents are follows the same format as the original paper. Here is the bibliographic information. This study was published in the journal Technology Forecasting and Social Change in 2022. It focuses on IoT and smart connected objects, such as wearable devices like smartwatches, by extending the technology acceptance model to include new variables. This is introduction. This study focuses on intelligent sensor-based technologies, SEO, like smartwatches, which are rapidly spreading through wearables, smart homes, and digital healthcare. While prior research emphasized technical aspects, it often neglected users' emotions and cognitions, such as perceptions and motivations, which are crucial for understanding actual adoption and resistance. Using the technology acceptance model as a base, which links perceived usefulness and ease of use to adoption intention, this study adopts a user-centered approach to better capture emotional and cognitive factors beyond TAM scope. This study enhances the technology acceptance model by incorporating the three major theories. The diffusion of innovation theory explains that adoption varies by user groups like early adopters and late majority, influenced by individual innovativeness. Uses and gratification theory highlights emotional needs and well-being as important factors driving adoption and continued use. Privacy calculus theory emphasizes that user weigh benefits against privacy risk. So, especially since smart connected objects handle personal data. By combining these three theories, the study proposes an expanded TIM that reflects different adoption stages and user experiences, aiming to guide user centered design and corporate strategies. For theoretical framework, Section 2.1 reviews technology adoption models, many of which follow the S-curve and diffusion of innovation theory that divides adoption into stages like early adopters and early majority. Among these models, the technology acceptance model is a leading theory for explaining individual technology adoption. Recently, TAM has been widely applied to hedonic technology, those used for leisure and home, which supports its relevance for studying the adoption of disruptive technology like SCO. The study conceptual model classifies variables influencing SEO adoption into several groups. Adoption perspective, intention to use, and real use. Technology benefits from TAM, perceived usefulness, and perceived ease of use. For self-improvement benefits, there are well-being and social image, reflecting quality of life improvement and social recognition. And last, personality traits are innovativeness and privacy concern, which moderate the relationships within the model. The list of hypotheses is shown in Table 2 and mentions the influence of relationships between individual variables explained earlier. For example, H1 hypothesis that the user's intention to use SEO will have a positive effect on actual uses. In addition, the table shows other hypotheses that based on combinations of the variable for the materials and methods. Regarding the data overview, the data collection period was from January 2015 to March 2018, and the subjects were users aged was 21 to 27 who were enrolled in a French master's course and used smartwatches. The sample size was 702, and the measurement items correspond to the variables explained earlier. To explain the sample classification in more detail, late majority refers to users who started using SCOs in the late marketplace and have used them for less than 1 year. Early majority refers to a group that entered later than early adopters but earlier than the late majority. Early adopter referred to long-term users who adopted the technology earlier and have used it for more than 3 years. The study was conducted using a questionnaire and measurements were made using a 5-point Likert scale. The validity of the measurement scale is verified. In Table 3, factor loadings indicate whether each item well represents the corresponding variable, and it should be 0.7 or higher. This is measured for each individual item. Cromwell alpha coefficient is considered reliable when it is 0.7 or higher, and it indicates how consistently multiple items measure the same concept. The IV value should be 0.5 or higher, and it reflects how well the set of items explain each concept based on average variance. Calculation results show that the scales have high reliability and validity, and the variables also satisfy the normality conditions required for regression analysis. Next, Leibniz test is used to analyze the mean differences between users groups based on SSEO adoption stages. If the p-value and the test less than 0.05, it is judged that there is a significant difference in variance between groups. And the larger the f value, the higher the likelihood that the average difference between groups is statistically significant. To briefly describe the results from each indicator across groups, innovativeness was highest in early adopters, followed by early majority and then late majority. Intents to use and real use were also higher from those with more user experience. PU, and WB showed the same pattern. Social image followed a U-shaped patterns, and privacy concern was measured lower in early adopters who entered the market earlier. Discriminant validity verifies whether the variables being measured are distinct from each other. Using ABE values, the reliability of the variables is confirmed. The diagonal values represent this. The values outside the diagonal represent the correlation coefficients between variables, and if the diagonal value like self-correlation is greater than the intervaluable correlation, then discriminant validity is secured. As a result, the late majority showed relatively strong correlations between variables, while the early adopter group showed weaker and intervariable correlations, confirming clear factor independence. For the result, the multivariate normality analysis result confirms the study's findings are acceptable. and thus a structural equation model is applied. As shown in Table 6, the vectorial invariance analysis results show that the model fit indices meet the required criteria and are deemed appropriate. When checking the individual values, we can confirm that the model fit improves as user experience increases. This is the hypothesis testing results page. Table 7 shows the path coefficients between each variable, which indicate the direct effect of one variable on another. In the case of H1, intention to use had a positive effect on real use only in early majority and early adopters, confirming that H1 is supported only in early groups. H2A refers to whether the perceived usefulness by users leads to actual use, and this result was also supported only for early groups. H2B refers to whether perceived usefulness leads to the intention to use, and this result was supported only the late group. H3A refers to whether the perception of ease of use leads to a perception of usefulness, and it was supported in all groups. H3B refers to whether the perception of ease of use leads to the intention to use. It was supported only in late majority and early majority groups. H3C refers to whether the perception of ease of use leads to actual use, and it was supported in all groups. H4ABC referred to whether the perception that life quality improves when using the product leads to intention to use, perceived usefulness, and perceived ease of use, and it was supported in all groups. H5A and B refer to whether social image leads to intention to use and life quality improvement, well-being, and they were supported in all groups. H5C refers to whether social image leads to perceived ease of use, and it was supported only in the late majority group. Afterwards, the moderating effects of variables were confirmed as shown in Table 8. H6 tests whether the effects of H1, H2A, H2B, H3A, B, C become weaker when privacy concerns are high and stronger when privacy concerns are low. Partial support was found as negative moderating effects were confirmed only in some relationships. H7 tests whether the effects of H1, H2AB, and H3ABC become stronger when consumer innovativeness is high and weaker when it is low. As shown in table, this also showed partial support. For the discussion, this study presented a new perspective on technology innovation diffusion by analyzing consumers' adoption and diffusion behavior through cognitive and emotional factors such as privacy concerns, which have not been all well addressed in previous studies. It demonstrated that the acceptance of SEOs varies depending on user experience, adoption stage, and innovativeness. As a result, it was found that early adopters are more sensitive to well-being, emotional value, while the late majority are more sensitive to practical value. Users evaluated the usefulness and ease of use of SEO highly, and such practical benefits were mentioned as key factors in technology adoption. It is also mentioned that the need to balance personalization and privacy protection. For the conclusion of the study, this study highlights that IoT, SEOs, and AI are disruptive technologies that improve user quality of life and business performance by real-time data collection and analysis. It acknowledges uncertainty around these technologies and suggests direction for future research. Limitations include sample representativeness and focus on a single device, like smartwatches. So future studies should be used diverse international samples and examine SEO adoption based on use purpose and motivation for broader generalization. And it is the end of the presentation. Thank you for watching.